So we're going to take care of the last part of this one, which are slope fields. Okay, what we did up here is these are algebraic solutions. Okay, what slope fields are is they're a graphical solution to an antiderivative, and it shows all of them, including all the plus c's. Does not matter what c is it gives us a map for all of them. Okay, so in other words, it shows us all the c's. And what they are is they're the slope or value of the derivative at any given point. Okay, and just so you know this, we may not be able to find the antiderivative of it, but we can always draw a slope field for it. Okay, so how do we draw a slope field? Given a derivative, we're going to compute the slope at each point on the graph and draw a mini line at the point with the computed slope. So if we find a slope of 1 at a point, we're going to draw one that has a slope of about 1. If we have a slope of 2, I'm going to make it steeper, and that has about a slope of 2. If we have a slope of 0, it's going to look like that. An undefined slope would be a vertical. Okay? We're going to repeat for each point, which you may say, oh, that's a lot. Yeah, that's right. But the results are the general solution. And then we're going to pick a particular point and actually draw in the graph just for that one. Okay? So if you look at this one, our differential equation, which this is one we can actually integrate, but we're not going to do it, is y prime is equal to x, which that means the slope at any point on the graph is equal to the x value, if you really want to think about that. Okay? It does change, but it only is dependent upon the x value. We'll do this part at the end, though. All right. So this means wherever x is 0, the slope will be 0. So if you think about it, isn't x 0 all along here? Mm-hmm. So I'm just going to draw in a slope of 0 at each of those points. Okay? And so when x is 1, which is all along here, I'm going to have a slope of 1. And I'm just eyeballing a slope like here. So a little slope of 1, slope of 1, slope of 1, slope of 1. Our key points are where the slope is 1 and the slope is 0. Okay? Now I want you to think about this too. If that's also, I should say. Well, the other thing is over here where x is negative 1, it's going to have a slope of negative 1. So I'm going to draw that in. I have some symmetry here, which makes it my life a little bit easier. Okay, now when I go out to when x is 2, the slope is 2. So I'm going to kind of line up here and here and just kind of draw one in like that. So we know as you move to the right, it is getting steeper. Okay, and as I keep going over, this is going to now have a slope of 3. So look at this, I go up 3 and over 1. So I'm kind of aiming for that point. But I'm getting steeper. But all of those along there should be the same. Okay? Now we got to go over here. X is negative 2, so my slope is going to be negative 2 here. Now this one isn't very complicated because you have so many places where the slopes are the same. And this would have been negative 3. All right. So what this is this kind of gives us a map of all the different antiderivatives for this. And they all differ by a constant. If I pick this one, I get one in here. If I get this one, I draw it down here. Okay? But now we're going to draw in one particular solution. And I've got a crazy colored pencil here I'm going to use. But here we go. So I'm going to go down to the point 0, negative 2, which is right here. And I'm now going to eyeball where that goes. I kind of have to stay within my lines here. I know it's 0 here. I know it, so I'm just going to curve it around and approximate where it goes. I'm not perfect, but this is an approximate curve. So that is our graphical solution. So given this slope and through that point, I drew that curve. Okay? All right, so we're going to go over and do this one. Second one here says, we're going to find that, by the way, this is the general solution before I do that graph. So we're going to do the general solution for this. And that means the slope is equal to the value of x minus y. That is the slope. So one way to think about it is, where is the slope always 0? The The slope is 0 whenever x and y are the same. So where does that happen? Along here. So we may have some symmetry that gets built around that line. Here our symmetry was all about there. Okay? So I'm going to pick a point here. So now when x is 1 unit bigger than y, I get a slope of 1. So if you look at here, this is when x is 1 and y is 0. So I get a slope of 1. At 2, 1, I get 2 minus 1, it's 1. So all along here, I get a slope of 1. Which actually, figure out what that is? That's an asymptote. That's a slant asymptote. Okay? So now we go over here. This would be the point 2, 0. Right? So that would be 2 minus 1. Now that would be a slope of 2. So I'm getting steeper then. So this is the point, what? 3, 1. 3 minus 1 is 2. So you're starting to see that all along there, we're getting exactly the same slope. And at 3, 0, I get 3 minus 0. That slope is now 3. So it's even steeper there. Okay. If I go here, this is at the point, that's 3, negative 1. So when I substitute that in, I get 4. So I'm even getting steeper. So all along here, it's going to have a slope of 4. All right. So we're getting, if you look, here it was 0, here it was 1, here it was 2, here it was, 1, 2, 3, 4. Now I got to go a little bit more on the other side. So if I pick this point, this is 1, 2. So when I plug in 1, 2, my slope all along there is negative 1. So if I plug this in, this is the point 2, 3, it's negative 1. Okay? Now if I go over here, the next point, if I look at that's 0, 2, 0, 2, it's negative 2. So I'm just kind of eyeballing it down here, eyeballing it down there. You may look at this thing. This is a mess. Actually, it's not. Okay? So last one I'm going to do, I'm going to do one more. We won't get them all in. If I pick this is 0, 3. So that's my slope all along there is going to be negative 3. So we're getting very steeply negative. Okay. So I'm not going to do those corner points. But now I got to go draw my particular solution at 0, 1. Well, 0, 1's right here. And I'm going to kind of follow it. Well, if you look at it, it curves around and zooms up that asymptote. And it kind of goes vertical here. Okay? And that's what it looks like. So they're sometimes not easy to draw. We are just eyeballing them. We're staying within the realm of what the slopes are between there. We're never crossing those. Okay? There's my second one. Okay, so here I looked, as I said, you look for slopes of 0. Then where is it 1? Well, it's always when x is bigger than y by 1 unit. Where is slope 2 when x is bigger than y by 2 units? So that's one way to follow. All right, so let's go do the next one. Oops. Oh, there it is. So then we're going to do a couple matching ones down here at the bottom. Okay, so this one you end up getting, so what does this mean is the slope is equal to x times y, the y value minus 1. Well, let's figure out where the slopes are 0, first of all. The slopes are 0 whenever x is 0, and the slope is 0 whenever y equals what? 1. Okay, so whenever x equals 0, I get a slope of 0. And whenever y is equal to 1, I get a slope of 0. Well, look at that. What does that give me there? That's a horizontal asymptote. This is just where a slope is 0. So now I'm going to just start picking points. This is the point 2, 1. I'm sorry, 1, 2. So that's 1 times 1 is 1. If I plug this is the point 2, 2. So I get 2 times 1 is 2. So it's getting steeper as I go that way. So wait a minute. 0, 1, 2. I bet it's something like that here. So this is a point 3.2. So that's 3 times 1 is 3. So it looks like it goes 0, 1, 2, 3. Well, let's check that here. Does that happen here? Probably not quite the same. But at 1, 3, I get 1 times 2 is 2. At 2 here, I get, we're just going to draw in a few points here. At 2, 3, that's 2 times 2 is 4. And here it's 3 times 3, 3, so I get 3 times 2 is 6. So you get different ways of it growing as you move out and up. So, okay, so let's look over here. And that is negative 1, 2. So that gives me negative 1 times 1. So it's negative 1 there. So if you look, we're getting symmetry about here. That was 2, that was 3. This one here, if you remember, that was a slope of 2, I believe. So it's going to be negative on this side. You keep getting steeper. So I want to show you what happens here. We also said it was, well, what happens whenever y is, at this point is x is 1, y is 0, we get a slope of negative 1. So it looks like it's now turning away from here. Here it was turning up, now it's going to turn down. So at 2, 0, I get 2 times negative 1 is negative 2. Sure enough. We have the same values as this one up there. So if this was flat, this was 1, so it's going to look like this and keep getting steeper. Same thing, this one is the same as that one. So you start seeing there are some patterns here, numerical patterns that go on. Okay, and this would represent all the solutions. So if I were to draw one in here, I didn't give you a point, it's going to look like this. But any point that would be here, it's like a black hole. It gets sucked right into the asymptote. So any point that starts here will never go away from it. Okay? All right, so it's a brief introduction. I do want to do some matching of these. Okay, we're always going to look for slopes of 0. Okay? And I want you to think about, I guess if we look at this one, where are the slopes 0? Well, that's when x equals y. Okay? Whenever x equals y, I get a slope of 0, and the slope is always positive. Okay? Well, this one is 0 whenever x equals y, and the slope is always what? Positive. Okay? There's no other one with a slope equal to 0 on it. So this one, 44, is this one. Okay? All right. Where is this? So what does this mean? The slopes are 0 when x and y are opposites, and the slope, again, is always positive. Well, whether opposites is along here, and I give you the window of this, and the slopes are always positive, so this one has to be 43. Okay. So what does this mean? Slopes are always positive, okay? But at 0, it will be 0. So the slopes are 0 at 0. Looks like this one. So it could be this one. Couldn't be this one, because the slopes are not 0 at 0. Couldn't be this one. But the slopes are always positive. Well, those are always little positive slopes. If you look at this one, they become what? They get some negatives. So this one here has to be 45. Okay. Now you notice some of these I kind of avoided. Well, where will this equal? I don't know if that's, this one's factorable. So if I square, that would be what? Y minus 5 times y plus 1. So it'll be 0 whenever y is equal to 5 or negative 1. It's 0 when y is equal to 5 or negative 1. Not seeing that one. When y is 5, so you'd have a 0 up here, or negative 1. Well, okay, so we'll come back to that one. This doesn't factor, but I want you to think about it is, well, let's go down and look at this one. This is kind of elimination. Whenever they're both positive, they're positive. Slope is positive. Whenever they're both negative, it's positive. So over in these two quadrants, it'll be negative. So that can't be this one. Here, it's always positive. Here, it's positive here, negative here. No, positive here, negative here, so it has to be 46. All right, so now we got to look at this. it looks like I'm going up, I'm positive, it flattened out a little bit, and then it goes up at about y is equal to 3. Well, maybe that is closer to 5. So I am guessing that this one's 42. Okay. This one I'm going to look at, well, I don't think it's ever equal to 0, but I'm only going to have positive slopes because I'm never going to get negatives out of here, so that is one thing that's always true. At when x is 0, the slope is 1. So when x is 0, the slope is 1. That's my key, slope of 1. So this one's 41. Okay? Here, whenever y is 0, my slope is root 5. So if you look along here, that is the same slope along y is equal to 0. So, okay, hopefully this helped. The multiple choice ones are always by elimination. And then the other ones are, so hopefully this is helpful. Thanks. Bye.